Okay, this note segment is regarding acids and bases, and we're going to first take a look at the properties of acids and bases. Some of the general properties. We'll define what an acid and base is, go over those properties, and then we'll talk about something called a neutralization reaction and why that's important. And then we're going to redefine acids and bases and using a different set of criteria, the criteria that's most often used for biology. Since your next course in sequence is biology, I thought it was important to give both definitions. So the definition, the first definition that we're going to look at for an acid is a compound that produces hydronium ions when dissolved in water. So let's take a look at that. So here I have hydrogen chloride. It's also known as hydrochloric acid. When I add hydrogen chloride to water, what happens is that the hydrogen chloride does something called dissociates. And what that means is the positive part separates from the negative part. And we know from naming compounds that the positive part's always written first and then the negative part. So the hydrogen separates from the chlorine. When that happens, this hydrogen becomes attached to the water, forming a hydronium ion. So if you notice, water with one more hydrogen is H3O, that's the hydronium ion. And then the chlorine, this other part that disassociated from the hydrogen, is kind of just left by itself there, okay? So anything that disassociates and forms a hydronium ion is called an acid. And as you can see from the chemical formulas for things, you can pretty easily pick out what's going to be an acid. Anything that has a hydrogen here at the beginning will disassociate. The positive part will separate from the negative part, the positive from the negative, and this positive part is hydrogen, and so it will attach to water and become hydronium. Now, not every single acid has hydrogen at the beginning. The ones that I give you in your test or on your quiz and ask you to identify, hey, is this an acid or is this a base, will be pretty clear like this, and not clear, not one of these tricky ones like acetic acid. When you get to honors chemistry, she'll explain to you how this also can disassociate and donate hydrogen. Okay, so some of the properties of an acid is they taste sour. So foods that you usually eat that have a little bit of a sour taste, like citrus fruits, lemons, grapefruits, limes, oranges, they all contain acid called citric acid. Vinegar contains acetic acid, and dairy products, once they're spoiled, they get that kind of sharp taste to them. They contain uric acid, and that's what gives them that kind of tartness. Another property of an acid is that when you place an acid on a metal, it will bubble and react, and that bubbling is just the hydrogen that's broken away from the hydrogen disassociating from the other part, the negative part. That hydrogen starts to bubble up in the form of a gas. And the third property of an acid is that it will change some substances' color in the presence of an acid. So we have these chemicals called indicators, and they're a substance that changes color in the presence of an acid or base. And one of the most common indicators is something called litmus paper. And there are two types of litmus paper, blue litmus paper and red litmus paper. If you place blue litmus paper in the presence of a acid, it will turn from blue to red. And how you remember that is blue to red acid. So if you notice, I've placed a piece of blue litmus paper against this apple, and apples contain several acids, malic acid, ascorbic acid, and citric acid, and so it turned the litmus paper from blue to red. Now, do you notice it's not really that blue, it's more purple, and this isn't really red, it's more pink? Okay, but pink and purple don't rhyme with blue and red, so let's just keep it as blue and red acid. Alright, so that brings us to bases. Base is another kind of chemical that will dissociate in water, but this time when the base dissociates in water, it creates the hydroxide ion. This is one of the polyatomic ions that we have been using to name compounds. So let's take a look at how that happens. Sodium hydroxide is a base. So when I place sodium hydroxide in water, the positive part breaks from the negative part and releases this hydroxide ion into the water. Now this hydroxide ion is not going to combine with water like the hydrogen did. Remember, in an acid I broke the hydrogen off from the negative part, and the hydrogen combined with the water and made that hydronium ion, H3O. Here the hydroxide ion is just kind of free to roam around there in the water along with the sodium ion. And again, if I give you some chemical formulas and you notice that the negative part of the formula is hydroxide, then chances are it's a base. So at this point you should be able to identify, if I give you a chemical formula, if something is an acid or if something is a base. If it has hydrogen as its positive part, chances are it's an acid, and if it has hydroxide as its negative part, chances are it's a base. So some of the characteristics of bases is they're very bitter. Unlike acids, which are sour, bases taste very, very bitter. And a wonderful example of that is chocolate. Cacao beans, which are the cocoa bean, contain a base, and that base gives chocolate a very bitter taste. And we've all done this, where when you were little and your mom was making something and she had that baker's chocolate and it looks like a chocolate bar, and you're like, oh, can I have some of that? Your mom's like, no, you don't want that, it doesn't have any sugar in it, it's really bitter. No, please. And you think it's going to taste like a Hershey's bar, and you steal a little piece of it and you taste it and it tastes awful, right? Because a Hershey's bar has the cocoa in it, plus it has lots of sugar and milk, and the baker's chocolate just doesn't have the sugar in it, so it has that very bitter taste. A lot of medicines that you take are basic, especially antibiotics, so they have that awful bitter taste and they leave that lingering bitter taste in your mouth. Another characteristic of bases is that they're real slippery to the touch. Clorox bleach. So Clorox is a very famous base, and if you ever felt Clorox bleach, it's very slimy, feels very slimy. Many soaps and cleaning products contain bases, and so they're very slippery to the touch. Another thing that is very slippery to the touch are stones that are in like a stream or a river, because as water moves past the stones erode and they free up some bases, some chemicals that are found in the rocks, and those bases make the rocks very slippery. Bases also change indicators' color in their presence. So we said there's two types of litmus paper. There's blue litmus paper that turns red in the presence of an acid, and there's red litmus paper that turns blue. Now another name for a base is an alkali. So the poem that goes with this particular to help you remember is red to blue alkalu. So another indicator is phenolphthalein, and it's a clear chemical, and if I place phenolphthalein in an acid it remains clear, but if I place it in a base it turns a real bright purplish pink like a magenta. Okay, so there are some indicators that change color in the presence of a base. There's a very natural form of indicator, these beautiful hydrangeas. If you ever or you know somebody who has hydrangeas in their garden, hydrangeas the color of the hydrangea comes from how acidic or basic the soil is. If your soil is very acidic, then your hydrangea will bloom blue. And if your hydrangea is growing in kind of basic soil, then your hydrangea will grow pink. So if you ever wanted to amaze little kids, you could take a hydrangea plant and you can say, I'm going to do some magic, and you add some vinegar to a pink hydrangea and say, over the next few days this plant is going to go from pink to blue. And because now it's in a very acidic soil, because vinegar is acetic acid, it will go from pink to blue. Okay, so if you recall, at the very beginning of the course when we were doing safety, we were watching that video on incident at Jefferson High, and they said if you spill an acid, you pour a base on it. If you spill a base, you pour an acid on it. And the reason that we do that is because of something called a neutralization reaction. If I have an acid and I want to neutralize it, I mix it with a base. If I have a base and I want to neutralize it, I mix it with an acid, because the reaction between an acid and base will always make salt and water, which are very tame things. Bases can be very harmful to the skin, can cause burns. The same thing with acids. Clorox bleach will take the color right out of your clothes. Acids will burn your skin, burn through your skin. So if I want to neutralize them, all I have to do is, if I have an acid, I add a base, and it makes two very kind of tame things, salt and water. So when you have stomach acid and you're taking a Tums is very basic, and it turns the extra acid in your stomach to salt and water, which your body easily gets rid of. So salts are what is produced when the negative part of the acid combines with the positive part of the base. I get the salt, and then the positive part of the acid and the negative part of the base make water. So let's take a look at that. So now I wish they would have just left this as HCl. So if we had an acid, HCl, and we have a base, NaOH, the negative part of the acid, the Cl, and the positive part of the base come together to form NaCl, which is salt. That's the kind of salt that we sprinkle on our French fries. And then the H from the acid and the OH from the base come together to form water. So it doesn't matter what acid or what base you put together, the positive part of the base and the negative part of the acid will form the salt. So you have some homework papers in your unit review that ask you what salt is being formed. You just take the negative part from the acid and the positive part from the base, and you combine them together and you make that salt. Okay, and then there are they talk about many different salts that can be formed, and your book gives you a nice list of salts and their formulas and what they're used for. Okay, and all of these can be created by reacting an acid with a base. Okay, so that brings us to the last section of the notes, and this section is about the second kind of definition. And we said that our definition of an acid is that an acid is something that breaks apart in water and releases hydrogen to combine with water to make the hydronium ion. And then we said that a base breaks apart in water and forms the hydroxide ion. But there is another definition of an acid and base as well. We can define an acid as being a proton donor and a base as being a proton acceptor. And the reason why we do this is because this allows us to make more things be considered an acid or a base. For example, in our first definition, water doesn't form hydronium ions. If I break water apart, the H and the OH, it doesn't form hydronium ions. It doesn't form hydroxide ions. So I can't really call water an acid or a base. But if I use the example of a proton donor or a proton acceptor, then water, depending upon what it's mixed in, can be actually considered an acid or a base. And this is the definition that we use in biology, so that's why I'm making you familiar with it. Okay, let's take a look at this. So here I have water, and it's mixed with an acid, the hydrochloric acid. Hydrogen is going to break free and come over here. So this is getting rid of a hydrogen. It's donating a hydrogen. Remember, hydrogen is a proton. If you remember from Unit 2, when we had our nuclear reactions and we had protons flying out, we used hydrogen as our symbol for the proton, remember? So I am donating this hydrogen, donating this proton to water to form the hydronium ion. And the hydronium ion, the water then is accepting the hydrogen, accepting the proton, so it can be called a base. So this is a base, this is an acid. Okay, and we'll be forming this. Now don't worry about this side of the reaction. In honors chemistry, you'll talk about why I now call this an acid, why I now call this a base. We're not going to worry about that here. I just want you to make sure that if you look at this side of the reaction and you see that hydrogen, you look over here and you see that hydrogen went to here, that obviously this is accepting a hydrogen, so water is the base in this example, and this gave up the hydrogen, so this hydrogen chloride was the acid. Now here in ammonia, when I add ammonia to water, it will actually take a hydrogen from the water and attach it to itself. So since hydrogen is going to the ammonia, the water, becomes the acid. It's donating a proton, it's donating a hydrogen, and the ammonia becomes the base. It's accepting a hydrogen, it's accepting a proton. So if I give you an equation like this, could you tell me that water was acting like an acid here and the ammonium was acting like a base? I hope so. Okay, that's it for acids and bases, and we'll be taking a closer look at them in the laboratory when I return to class.